We can use the definition to find the derivative, but it becomes a little bit tedious doing the same thing over and over again, and it's a long process. So mathematicians have been able to create some general results. They proved them using the definition, but now we can use those results to easily find the derivatives. One of them is the power rule, which is if f of x is, let's say, x to the power r is some constant, r times x to the power r minus 1. And this works for any r. It may or may not be defined for certain x. If the power becomes negative and x is 0, then it may not be defined. But that you have to see where you're looking at. But in general, this is the power rule to find the derivative. Also, what is the derivative of a constant? Derivative of a constant is 0 because there is no change. We're talking about instantaneous rate of change. If it is the same everywhere, then its derivative is 0 because it's not changing, right? And if we are looking for derivative of k times some function, k times the derivative, right? And if we are looking at, so these can be combined in a finite number of times, addition, multiplication by a constant, and then the function can be power rule. You can apply these a finite number of times to figure out what the derivative should be for a function that, like a polynomial or a combination of functions. But there are a couple of other things that we need to know. One is called the product rule, right, which says the derivative of the product of two functions is f prime g plus f g prime. And this all can be derived or proved from the definition of derivatives, and it has been proven, but in this course we will just be using the result. The other is the quotient rule, where the denominator is not 0. Gx squared